Welcome to the Java course. This session is on Java fundamentals. So we are going to discuss on programming languages, translators, and discuss how Java is different from other programming languages. What is a language? Language is a medium of communication. So if I want to talk to someone, I need to talk in a language, and that language should be known by that other person. Programming language is a language which we talk to the processor, and the processor should be able to understand that. The language that processor understands is machine language. So what is machine language? It's nothing but a language which can support only binaries, which is 0 or 1. It basically represents the on or off switches in the integrated circuits. So that's what processor just understands only zeros and ones. So if you want to communicate anything to processor, you need to specify in zeros and ones. So based on that signals, it is going to perform any operations or show some responses. There are other popular programming languages. We have assembly language, Fortran, COBOL, Pascal, C, C++, Java, and Python. Coming to translators, so we have machine language, which is zeros and ones that we feed into the processor, and processor is going to provide a response for us. This programming language or the machine language is very difficult to code for developers. So they try to invent some other languages which is going to ease their job. So they first invented like assembly language, which is more easy to write and do coding compared to the machine language. But what processor understands is only machine language. So you need to convert your assembly language code to machine language so that the processor understands. So who does the conversion? A translator. So in this case, the translator is called as assembler, which is going to take the assembly language as the input, and it is going to basically convert that into machine language. Slowly, even this assembly language is a little bit hard to code actually. So they came up with a lot of new languages like Python, Fortran, COBOL, Pascal, C, C++, Java. Like these are all basically new programming languages that came into the picture, and it tries to address some problems, or it is basically trying to ease our job of writing the programs actually. So basically, let's take C or C++. What it's going to do is you can easily do a coding. As you see here, it will be more easy to understand compared to what you wrote in machine language or in a assembly language. So what the C++ is going to do is it is going to take the C code and it is going to translate into assembly language, and assembly language is again going to translate that into machine language. So the translators can be, so here the translator we call it as a compiler, which takes the C program and compiles that into another code, which is the assembly language code here. So this is what we call it as a translators. And basically these translators are helping us so that it will increase our productivity, and it is going to be easy for the programmers to do the coding. What is operating system? Operating system is basically an interface between the user and the processor. So you have worked on Windows, Apple, Mac OS, and Linux. These are all basically operating systems. Say if I want to do, let's open up a file and read the contents. So as a user, I'll be clicking on a mouse and I'll just open up a file and read the contents in the file. So internally what happens is basically each actions that the user performs, you are performing like double clicking a file, and that instruction is that action is sent to the operating system. Operating system is going to convert what this user is trying to do in a machine language format to the processor, and processor knows what it actually has to perform for that actually. So it is basically abstracting all the things and giving you a environment where you can do a lot of things, and internally it is going to convert that things into a language or machine language which is understandable by the processor. Let's talk about how C programs gets executed. C is again a language. For that we'll talk about an analogy. So let's say you wanted to build a house. You approach a engineer to build a house, and you say in words like I need this and that, like that. So he basically converts whatever you wanted to build a house. He converts into a specifications, right? So he basically converts into a specification, but he has a group of workers who knows only French. Okay, so he gives a specification uh, to the French workers. For them, he needs to give the instructions in the French language so that they understand and they do the work. Similarly, he also needs to deal, let's say if he needs to deals with the Spanish workers, he cannot give the French instructions to the Spanish workers. So for that, he needs to basically uh, convert the requirements that the customer gave into Spanish instructions. Okay, so here, if you see, um, a French group of workers receives a different instructions, and Spanish group of workers receives a different instructions. So you need basically two supervisors, one who knows French language, who can produce the French instructions, the other one who knows basically the Spanish instructions. He needs to translate that into he needs the to put the instructions in the Spanish. The same way C works actually. If you take C language, you need a compiler, and this compiler is going to be different for different operating systems. Let's say this French one is assume is a Windows, and this one is a Spanish is a Linux. So in order to work with Windows, you need to have a compiler which converts your instruction, that is a C program, into something which will be understood by the Windows operating system. And you need a separate compiler, C compiler, for converting your instructions into the instruction that is understood by the Linux operating system. So that is where we call that, we need different compilers in C to translate for a particular operating system. And the code or the specification that is produced by the compiler is called as the object file. And this object file is a non-portable file. Why we say it is a non-portable? Because the object file that is produced by the Windows C compiler cannot be running in the Linux one, because Linux doesn't understand what is it. It is just like giving a French instruction to a Spanish guys. It just works like that, right? So C code or the compiled code of C is non-portable. That means whatever compiled for one environment will not work for the other environment. We'll see how Java execution is going to be different than the C execution in a while. So we'll take the same analogy. Let's say you are giving your requirements, and the supervisor is going to convert that instructions, and in this case he is going to provide the instructions only in one language, which is going to be English. So he's going to provide the instructions in the English. Whatever requirements I give, he's going to convert that into English instructions. Now he needs to work with the French people as well as he needs to work with the Spanish people. So what we are going to do is we are going to hire two persons here. One guy who knows how to convert the English instructions into French instructions. We're going to hire another guy who is going to work and convert English instructions to Spanish instructions. So these guys know how to convert from English to French and English to Spanish. Right. So here is how the Java model works. You give the Java program, and the compiler is going to convert into a bytecode or a class file. So basically, if you see here, there is only one compiler. Whether you work it with Windows or work it with Linux, the compiler is going to produce one code, which is the same English instructions. And this English instructions is going to be taken up by the JVM and convert it into the code which is understandable by the appropriate OSs. So we call so the Windows compiler for Java or the Linux compiler for Java is going to produce the same byte code. And the byte code, whatever, if you're working in a Windows environment, you type a Java program, you compile a Java program and take a byte code, the result code, and you can just put this Java code on the, sorry, I mean to say the class file into a Linux environment, and you can still run the program in the Linux environment. That's how Java is different from the other languages. So so it is called write once and read, run anywhere. So this is how the Java program execution works. You have the Java code, you take to a compiler, and compiler is going to convert into a bytecode, and the bytecode can be taken into any JVM, and that JVM is responsible for converting your bytecode into the code that is understandable by the underlying OS. Okay, let's try to understand what is the difference between JDK, JVM, and JRE. JDK stands for Java Development Kit. So it has all the libraries, or I would say something which is helping you to convert your classes, convert your Java files to class files, and it is also providing an environment for running the the class files whatever you have compiled. And you have JVM and JRE. JVM stands for Java Virtual Machine. JRE stands for Java Runtime Environment. So let's see what is the difference between JVM and JRE. Let's take another example for understanding that. Let's say you want to buy a smartphone, and any smartphone you are expecting is it should be able to it should have a touch facility. It should be it should support 4G. So these are the phone specifications in order to become a smartphone. So if you don't have a touch facility, then you will not really call that as a smartphone, right? But when I say I want to buy a smartphone, it's basically the specification. And what is the implementation? Anyone, Apple can come up with a smartphone, LG can come up with a smartphone, any other providers can come up with a smartphone. You see, like they are all basically doing the same specification. Like it is supporting the touch facility, it is supporting the 4G, so they are classified as a smartphone. They are called the implementations of the specifications. Okay, so the same concept applies to Java as well. We have JVM is nothing but the virtual machine, Java virtual machine, which says, hey, I wanted to implement, if you wanted to become a JVM, you need to take care of those things actually. It needs to basically convert the bytecode into an underlying OS code. So it will be providing the detailed instructions what needs to be achieved, and JRE takes care of how it needs to be achieved actually. So you can come up with a runtime implementations for the JVM, and all that you need to do is you have to meet all the specification that JVM provides you. Okay, Java is used in multiple applications. So you can use Java for developing a desktop applications. You can use Java for developing web applications, like whatever is you are seeing in websites and all these things are web applications. You can use it in mobile, developing apps, mobile apps, and mobile applications. You can also use Java for developing games and embedded systems, and also you can develop an enterprise application using Java. That's it for this session, and we will continue in the next session about how to install Java and start working on that. Thank you.